Alright, so let's just talk about few more about prime number. So we say that given any natural number greater than 1, there exists a prime number which divides the value n. Alright, so if the number is a prime number, so we know that the prime number itself is divided by the same number which is a prime number. Okay, so that's proof that. But if the number n is not a prime number, still there must be a prime divisor. Okay, so and as we know that from our last couple of example, we know that each of the number we can actually represent them as a multiple of some prime numbers. All right, so like that. Or also we saw that each prime number has each composite number has a divisor which has a prime divisor less than, okay, less than or equal to square root of n. Okay, so that says that given any natural number which is greater than n, there exists a prime number where the number divides that where the number prime number divides the natural number. So we say that there are infinitely many prime numbers. Okay, I mean the number of prime numbers, it's not a list, finite list. Okay, it's there are actually infinitely many prime numbers. So how we can prove that? So let's assume that this fact is false. Okay, means there are a list of fixed a fixed finite list of prime numbers. Okay, we are saying that it's a set. Okay, it's a set of prime numbers and this set is a finite set. All right, so we are saying that assuming that it's a finite set. Okay, all right, now let's find out p1 times p2 p3. Okay, and let's do the multiplication of all of them, plus let's do plus 1. Okay, all right, so let's assume this is another number and we are saying that this number is n. Okay, now from the last fact we are saying that given any number, any natural number, n has a prime divisor. Okay, now this one is obviously a natural number and it must have a prime divisor. Okay, so let's assume that the prime divisor here is pi. So we are saying that the prime divisor pi, it divides n. Okay, that means pi divides the whole number p1 p2 p3 pt plus 1. All right, so as this is a list of fixed finite set. Okay, this is a finite set. All right, so obviously that prime divisor obviously belongs to this set. Okay, so we are saying that that's a finite set, so obviously this prime number that we are talking about, prime divisor we are talking about, that divides this number n, obviously that belongs to our fixed finite prime number set. All right, and from that number we can see that obviously this number also divides the whole number. Okay, my means this number, so like p1 p2 p3 pt, because pi already belongs to this set. All right, so here sum of where pi is there. Okay, so pi divides this whole number. Now we are saying pi divides this whole number. Okay, multiplication of all the prime number, and also pi divides this number, the multiplication of all prime numbers, plus 1. Okay, all right, so what does that tell us? Pi also divides 1. So this is only possible if pi divides 1. Okay, but that's a contradiction, right? Any other number, I mean pi prime number, the definition of prime number means it's an integer number. Okay, And integer number, a prime number is not 1, so obviously that's greater than 1. All right, any other integer number, okay, it cannot divide the value 1. Okay, so that's a contradiction. So that's a contradiction. So that means, that proves that we are what we are assuming first, that PR is a finite set, it's false. Okay, that means there are infinitely many prime numbers. All right, so these are some properties that we have learned here. I mean, just the definition of prime number, how we can find out whether a number is prime or not. Okay, and some properties of prime numbers.